Do we have a GCF? No. So we are looking for two numbers that multiply to 45, add to 14. What would it be? Positive 9, positive 5. So this factors into x plus 9, x plus 5. All right, second one. Do we have a greatest common factor? No. So we need two things that multiply to a negative 28. If they multiply to a negative, what do you know? One of them is negative. And they add to negative 3. So which one is negative? The bigger one. So what would it be? So this factors into n minus 7, n plus 4. Does it matter if you write n plus 4, n minus 7? No. All right, number 3. What can we take out of that? So if I factor out my 2, it doesn't go away, it just sits out in front. So it's a squared plus a minus 12. So now we have to factor this inside. So we need two numbers that multiply to a negative 12 and add to a positive 1. Positive 4, negative 3. So the 2 just stays out in front. Then we have a plus 4, a minus 3. Number 4, what can we factor out? 4. That leaves us with p squared minus 6p plus 5. So we're looking for two things that multiply to positive 5, add to negative 6. So multiply to a positive, they have to have the same sign. Add it to a negative, so they're both negative. Negative 5, negative 1. So we have a 4, p minus 5, p minus 1. So we have been working on that. We did it last Wednesday and Thursday. They were on our quiz Friday. We practiced them again yesterday. Are they getting easier? Okay. So today, we are going to continue with problems like this, but they're going to have something else. They are going to have a coefficient in front of our x squared. And that coefficient may not necessarily be a greatest common factor that we can factor out. So there are lots of different methods for factoring these. But first of all, if I teach 4 different methods, that's just confusing. And second of all, I'm trying to stick with the method that is the most similar to what we have been doing. So I'm going to teach the slip and slide method. If that really confuses you and you don't catch on, I can show you other ways. But I think this will probably be the best so it's not totally different than how we've been working our problems so far. So the first thing, we always have to look for a GCF, no matter what. If we don't have a GCF, then we are going to slip the coefficient, the a, to the end of the trinomial and multiply it with c. So, for instance, if I look through this problem, okay, do we have a greatest common factor, 2x squared plus 5x plus 3? No. So what I'm going to do is slip the 2 to the end. So then it's x squared plus 5x, and at the end, I take that 2 times the 3, so it's 6. Now, this is one of the basic trinomials that we were working with. So this should be something we can factor. We need two numbers that multiply to positive 6 and add to positive 5. So it factors into x plus 3, x plus 2. Now, the problem is Was that for the original problem? No. If I multiply this out, I get x squared plus 5x plus 6, not what I started with. I got here by multiplying my 2 to the end. So to undo that, I have to divide my 2 back. So I'm going to divide each of those things by 2. Right? So we're dividing by whatever number we slipped. When we look at this, 3 over 2, does that reduce? No. So for my final answer, we're going to slide that 2 back in front of this x. So it's a 2x plus 3. Right, over here, 2 over 2, does that reduce? 2 divided by 2 is just 1. So there's nothing left to slide back over, it's just x plus 1. How can we check ourselves on these? This is my answer, but if you thought you had made a mistake, you could check. 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. 3 times 1 is 3. And if you add like terms, you get 2x squared plus 5x plus 3, like we started with. Alright, so that's probably a little bit confusing. We're going to go through a lot of examples. Do you have any questions so far? So let's try another one. First, this method will not work if you have a greatest common factor. So you need to check if you have a greatest common factor first. Do we have anything we can take out? No. So first we are going to slip this 5 to the end. So we have an m squared minus 17m, and what does this become? So now it's like problems we were doing for a warm-up. I need two things that multiply to a positive 30 and add to a negative 17. So that's m minus 15, m minus 2. All right, but I started my problem multiplying by 5. So now we divide each of these by 5. Okay, 15 divided by 5 is 3. That's not a fraction, so we just keep it. It's m minus 3. Can you reduce 2/5? So we just slide the 5 back in front of that m. So then it's 5m minus 2. We don't have any fractions left at the end. Is that okay? Let's try some more. 6y squared minus 5y minus 4. Do we have a GCF? No. So what's the first step? Move the 6 over. We're going to slip that down to the end by multiplying. So we have a y squared minus 5y minus 24. Now we do our easy method. So I need two things that multiply to a negative 24 and add to a negative 5. Negative 8, positive 3. So we have y minus 8, y plus 3. What next? Yeah, we started out multiplying by 6, so now we divide by 6. Can't those reduce a little bit? 8 over 6 reduces to what?
3.
And 3 over 6 is 1/2. Okay. So now, there's still fractions, so we have to slide the denominator up in front. So it ends with 3y minus 4 and 2y plus 1. So that one did kind of have an extra step because my fractions could be reduced. They have to be in lowest form before you slide that number back in front. Did I lose anybody there? Why don't you guys try the next one? You guys having trouble coming up with the numbers that multiply to 60 and add to 11? So it looked like everybody started off on the right track. You guys all slid the 12 down. So you had c squared plus 11c minus 60. So we need two things that multiply to a negative 60 and add to a positive 11. So first of all, we have to have a positive and a negative, right? Bigger one has to be positive. So if you get stuck, start going through the list. I can get 60 by doing negative 1 times 60. Negative 2 times 30. Negative 4 times 15, I've got it. So it's c minus 4, c plus 15. Now what? We started out multiplying by 12, so we divide by 12. Can those reduce? Yeah, they both can. So let's do that. 4 over 12 is 1/3. 15 over 12, you can divide both of those by 3, and we get 5/4. So to finish it, we can't have a fraction, so we slide the denominators back in front. So we get 3c minus 1, 4c plus 5. Okay. We're going to do a few more. Tell me what I do first. So we get x squared minus 11x plus 30. So multiply to a positive 30, add to a negative 11. I hear people whispering. What is it? Negative 5 times negative 6 is 30. Negative 5 plus negative 6 is negative 11. X minus 5. X minus 6. Now what? Okay, 5 over 3. Does that reduce? So we just slide the 3 in front. So 3x minus 5. 6 over 3. Does that reduce? 2. So that's just x minus 2. If there's no fraction left, you don't have anything to slide in front. All right. Why don't you guys try another one? Let's see where we're at. Why don't we do number 3? Down to 9. You guys find what multiplied to negative 18 and added to positive 3? Negative 3 positive 6. So m minus 3, m plus 6. Then we need to divide by 9. Okay, those reduce. 3 over 9 turns into 6 over 9 turns into. So you have to slide your denominators to the front. So 3m minus 1, 3m plus 2. All right. Are we doing okay with these? Okay. I want to do one with an extra twist. So everybody look at number 7. What do you notice about that one? Has a GCF. We could take out a 5. Now, does the 5 just disappear? No, it just stays in the front. So when I take that out, then we have 2k squared plus 15k plus 7. So now we slip and slide with the inside, and that 5 is just going to trail along. If it's in your way, you could even just come down to the bottom and write it and know that you're going to have 5 in front for your final answer. So we're really just working on this inside for a moment. That's k squared plus 15k plus 14. Okay, what multiplies to 14 and adds to 15?
1 and 14.
And then what do we do? So 1 over 2 doesn't reduce, so we slide the 2 in front, so 2k plus 1. 14 divided by 2 is 7, so there's no denominator, so it's just k plus 7. Okay, so greatest common factors, just like in the other problems we've seen, they stay in